So this little lecture is an add-on to really get you to think about how ways of knowing really represent a perspective on the world. So this lecture is a little more abstract, and I hope you find it helpful. So previously, in our last class, we tried to get at the difference between science and other ways of knowing. And these are, of course, the ways that we have been discussing in class that were gone over in our Zhangjiani text: intuition, authority, reasoning, empiricism. And we're trying to take and distinguish this systematic empiricism, or the scientific method, from the other ways of knowing. And so we talked about the story of the blind man and the elephant. And that is how many of these men who had no sight all wanted to learn what an elephant was. And so they all walked up to the elephant to learn about it and know what it was, but everyone touched it someplace different. And this person said, touching the tail, "I see an elephant is like a rope." And another one thought an elephant was like a spear because he happened to touch the tusk. Another one thought it was like a hose because he had the trunk, while another thought it was like a fan because he had the ear. The one who happened upon the leg said an elephant is like a pole. And the one who happened upon the side of the body said an elephant is like a wall. And each of their perceptions are accurate. This is empiricism. They each had these experiences, and yet none of them walked away knowing what an elephant was. And even though we have the good fortune of sight, we still have the same problem. And that problem is that we all wear filters. And the filter that we wear has us see and observe the world around us through a unique perspective that only we have. And so if any of us are in the same space looking at exactly the same thing, we're all going to pick up slightly different things, because we're filling in the blanks of our perception with our own experiences, our own biases, our own feelings. What we seek to do in science is remove the lens of bias. And this bias, of course, comes from our identity, our culture, the context in which we're looking at things. And that influences our perception, our behavior, and action. And this is what comprises our bias, our beliefs, our judgments, our assumptions. And we lack the capacity, any of us, to get rid of our bias. And so as scientists, we try to step back by putting into place strict methods that allow us to step back from our bias and observe things objectively, such that what I'm observing, if you were observing the same thing, you will see it the same way. There's none of my bias or your bias in the story. And then we talked about how this was the difference between objectivity and subjectivity. So subjective statements tend to be based on opinions, feelings, experiences. They aren't necessarily true or false. They're your truth, just like the blind man who felt the tail. Well, in that aspect, the elephant was like a, now I forget what he said. The one who touched the leg, his perception was, you know, in that sense, he was accurate. He did feel and experience the elephant as a post or a pole. And so it's neither true nor false. It's his truth, but it's not objective truth. In the case of subjective statements, interpretations will vary by whoever's making the interpretation. So each of those blind men would have a different interpretation for what the elephant was like. So it varied, and the source of the opinion would make a difference. Now, if it's objective, instead of being based on opinions, feelings, experiences, it's going to be based on indisputable facts, often numerically quantifiable facts. If a statement is made that's scientific, it's either going to be true or not true. It wouldn't be both, because we've taken out that individual lens of perception. This is going to be so objective that a robot or a computer could even interpret the numbers. The interpreter wouldn't matter. And regardless of who has stated the opinion, it's not going to make any difference. The interpretation will be the same. So this is what we try for in science, objectivity. But with all of that said, I did try to make the point that the subjective experience is also valid, and to link this to our programs here, and to two types of research, quantitative research and qualitative research. And so quantitative research is what we do when we're looking at objective data. Quantity means numbers. And so the data are going to be structured. If you had taken stats, you'll see that we're structuring the data into a spreadsheet. When we enter a value or a score for any individual, it's into a formula. So we put, if I ask you whether you prefer sweeter, salty, or spicy foods when you're stressed out, then whatever answer you put, I'm just going to write down either sweet, salty, spicy, no more detail. So I'm trying to fit it into a category. We'll be doing statistical analysis, which allows us to look for significant differences that can generalize to a problem. Generalize to a population. We can draw conclusions that are objective, meaning the conclusions are the same regardless of the interpreter. And finally, we might do things like surveys or experiments to gather data, to gather numbers that we can use for our quantitative research. Qualitative research, on the other hand, is likely to be more unstructured data. So if I ask you what kind of food you like when you're stressed, instead of just writing sweet, salty, spicy, you might say, well, it depends on the kind of stress, sometimes I like sweet and sometimes salty, and these are the factors that contribute. In this case, this word is spelled wrong, sorry, you would have a summary or conclusions that are summarized. So you might put all of the words that people are saying into a paragraph with quotes. You draw conclusions based on how you decided to organize the information, which might be different from the way I did. And so the conclusions are going to have that little bit of bias depending on what you chose to emphasize and write down. And you might see methods like interviews or focus groups as part of the method in qualitative research. And I pointed out that here at Diné College, we have an Indigenous Methods course, which usually I think uses both. It uses primarily a qualitative approach that's complemented by quantitative approaches. But because you're getting this in your Indigenous Methods course here, in our course, I focus on the quantitative research. Just a little bit more examples. In quantitative, you might see something like 20% of survey respondents bought ice cream today, whereas a qualitative researcher might say, I bought the ice cream because I saw it when I was in the checkout line. I wanted to treat myself. And so you see this is like rich, deep data, whereas this is sort of categorical data. 50% of people in New York strongly enjoy pizza. Okay, now we have some numbers, but the qualitative person would go deep. The individual experience would matter. I like a lot of toppings on my pizza: cheese, sauce, pepperoni, olives. Quantitative data might be something like this. On average, respondents rate their grocery store as a 3.5 out of 5, whereas qualitative would be going deep, would be telling the story. The grocery store has good options in general, but the lines can be long and they're often out of stock of my favorite brands. So again, we're going to focus on the quantitative here, but we will consider the role of qualitative. And if you take your Indigenous methods, the primary focus will be qualitative, supplemented by quantitative. And these are called mixed methods approach. Mixed methods, and it means that you have a piece of both. But again, in our class, the main focus is quantitative because you have other opportunity in other class to learn the qualitative. So the last thing that I wanted to point out is that there's often been argument between, let's say, religion or traditional knowledge and Western science. It's as if you either have one or the other. But I would argue that we don't need to fight, that they can both exist for different purposes. The Western science would tend to quantify and systematize the traditional knowledge, and the traditional knowledge informs and cautions the Western science. And so if there is, for example, a plant that traditional people, through their tradition, know about its healing properties, that's extraordinarily valuable. And there's so much respect in there that can be taught to Western science. Western science might be able to, let's say, understand the chemical makeup of it and determine quantities that would be appropriate to systematize its medicinal value. And so I would just say they inform each other. And there's a role for both. And the thing is, it takes mutual respect, and this is sometimes what we lack in these worlds of conflicting methods. So humility, tolerance, mutual respect, this is what we need in order to have this nice complementary relationship, and that's what I seek. So Western science has an optimal goal of determining this. Does A cause B? That's usually what we're trying to find out. So does cigarette smoking cause lung cancer? Or does exercise cause weight loss? And this word cause is so important, right? Because if we know the cause, then we can influence the cause and alter the effect. So we do find this to be a really important idea. It's linear thinking, meaning we're always wanting, to the extent possible, to draw a line between A and B, to know definitively that A causes B and there's not too much interference. So we want nice, tidy relationships. We know that most things in life are not linear, that they're much more complex. But in science, we're seeking to look for the linear relationship. And one thing that you need to be aware of that we're going to talk about in this content is that not all quantitative studies can determine causality. In fact, there's only one type of quantitative study that can determine causality,